Hello, this is George Earhart, and today's video is about how to make graphs in Excel. The first thing we'll talk about is how to make bar graphs. I have here a data set on students at App State transferring, yes or no, states their students being employed, and then how long they expect to take to graduate. So, bar graphs. Bar graphs we're going to use for one variable that is a nominal or ordinal level of measurement. So in this case, we have sex, transfer status, and employment are all nominal variables. So we can make a bar graph of those. Now, what we need to make a bar graph, if we just go like this, or if we go like this, down, and then insert bar graph. How many of you have seen a graph like this? Right, this is what happens if you naively create a bar graph in Excel. It's absolutely meaningless and pointless graph. Instead, we have to take one intermediate step first. Okay, we'll delete that. Here's where our count commands are going to be useful. So we go equals count if B2 through B282, I believe, comma, F. Okay, so this is looking for, oh, that didn't work. Oh, right, duh, sorry. So there are 100, so these are females, males, equals count if B2 colon B282 comma 1. Okay. Now that we have this count data, so we have counts in each of our two values of our variables, now we can go and put in a bar graph. And dun, dun. Here we have females at 135, males 145. Excel is bad because it cuts off down here, and really these two bars aren't as different size as they look. But in any case, we can go student sucks. We can have a title on that. We can so you can use various either layout options, whoa, not that, or you can add various things. So in any case, that's how you make a bar graph. The second kind of graph that we're going to see how to make are called pivot tables. This is when we have two variables, both of which are categorical, nominal or ordinal. So if we had one categorical variable, we use a bar graph. If we have two, and we want to show the relationship between those two, we use what's called a pivot table. So let's go back to this data and get rid of our bar graph. And find here, we're going back to Insert menu. We're going to add what's called a pivot table. Okay, so now when asked to select our data range, we're going to select all of the data that we want to use. We could select all of it, but let's just use these. So we're going to have the two variables that we want to put in our table, sex and did you transfer. We're also going to have that ID, that first column, and that's going to be our counting variable. Okay, so there were three variables here. So the first thing we're going to do, let's put sex in rows, and did you transfer here in columns, and then we're going to take our counting variable and put it down here. But we don't want to add them up. We want to count. We're going to count. Okay. Now, we can X out of this. So this was what? Female. Male. Oopsie. And other, I suppose, this is. And this is non-transfer. transfer. Okay. There's a blank, right? All we have to do is click on this. We don't want the blank. We can get out of that. We click on that. We don't want the blank. We can click out of that. And so now we see in a nice neat table here that among our 135 female students, 83 of them did not transfer, 52 did transfer. Among our 145 male students, 45 transferred and 100 did not. Okay, so this is how you make a pivot table. Some statistics packages will call this a crosstab. Either way, it's relatively simple to make. Okay, now we're moving from categorical variables, nominal and ordinal, to ratio variables. So we have a graphic form for a single ratio variable and then for the relationship between two ratio variables. For a single ratio variable, we make a histogram. So here's how you do it. Okay, so we're back to this. We have here years to graduate is a ratio level variable. So we're going to highlight this range. Well, 0. That is probably a mistake in our data. Nobody thinks they're going to graduate in 0 years. It's always good to check and see. But in any case, so we have that. We are going to go to Insert and a histogram. Dun dun. So here it is. Histogram. So we can see there are some at the very bottom. This is that weird 0. There's some others very low that I think are data entry errors. And there's some people, you probably know somebody that's on the 7-year plan, the 8-year plan. They're there, but most people are here somewhere between 3.5 to 4 years. It's possible to adjust the size of these, what are called bins, because a histogram, instead of a bar graph, a histogram displays not 1 bar for each value, but 1 bar for each bin. And a bin is anything in this range. So any value between 3.57 and 4.08 goes in a single bin, and that line gets drawn up. So that's how you make a histogram. You can adjust that with chart elements, layout, anything like that. So in a ratio variable, again, we use histograms. With nominal variables, we use bar graphs. Okay. Last but not least, we want to show the relationship between two ratio variables with a scatter plot, and for that I'm going to use a different data set. The final of the 4 graphs we're learning today is a scatter plot. Again, this is when you want to show the relationship between 2 ratio variables. We had 1 nominal variable as a bar graph, 2 nominal variables is a pivot table, 1 ratio variable is a histogram, and 2 ratio variables is a scatter plot. Here we go. So we're going to use this data, uniform crime reporting data from North Carolina by municipality. All of these are ratio variables. They're counting population, counting crimes. So first, we want to take the two data series that we want to use for our graphing. So let's use population and violent crime. Go down here. Okay, so we're going to copy those and move them to a new series because we're going to modify these a little bit in this particular data set. We could leave them alone, but let's put this here. We can go into paste. Okay. Okay, so I have pasted the population here and violent crime here. Now, we want to find out if there's a relationship between these 2 variables. So what we're going to do, we will highlight both data ranges. We'll go back to our trusty insert menu, go to, this is the scatter plot picture here, XY scatter. And again, remember from your Tufty reading, we don't want anything fancy. We do a simple scatter plot. And we get this. So, as you can see, roughly linear here. The larger the city, the more violent crime there is. This point here is pulling everything way out, makes it very hard to see. This is Charlotte, so let's do this here. Let's see if we can drag it up there and then get rid of Charlotte. Okay. Here we go. Delete these two. Okay, now you can see we're starting to get a little more detail, and we can see that line. It's not a perfect line, but it's a pretty strong relationship. We have ones out here. That is Fayetteville, I believe. Let's delete this. Again, in a normal sort of data analysis, you don't just cavalierly delete all your data, but so I can show you what's going on. There we go. Now we can see the relationship isn't quite as linear as we thought, but how do we know? Is it a line like this, a line like this? We can go to chart design and add a trend line, a linear trend line. So this is a line that tells you roughly, well, at 20,000 people, we expect there to be about 90, the violent crime rate will be about 90. Why some cities are above and some cities are below, I don't know. Perhaps in a CJ class you might talk about that. Are there different, I don't know, different demographics, different policing strategies? But one research project that this graph suggests might be to find out why some are up here and why some are down here. Okay, so that is the fourth of our 4 graphs. We had bar graphs, histograms for single variables, nominal and ratio, and then we had pivot tables and scatter plots for looking at 2 variables, pivot table for nominal and scatter plots for ratio. Okay, so those are the sort of the 4 basic graphs that you should know. I did not teach you pie graphs because you should not be making pie graphs. Yeah, I will spare you my sermon again, but don't use pie graphs ever.